Hello and welcome to lesson 1 of week 2. My name is Mildred. In this lesson, we are going to look at operators in Python. Now, operators are like symbols or special keywords that we use to perform different types of operations on variables and on values. In Python, we have different types of operators, and we are going to group this into arithmetic operators. Then we'll look at assignment operators, we'll look at identity operators, we'll look at comparison operators, and more. So when we looked at variables last week and we looked at how to concatenate or to combine two variables together, we use the plus sign. Now when we want to combine two strings with a plus, it concatenates them, right? But when it's two numbers, it adds them. So in Python, the plus sign is the addition operator. So when you want to add two variables or two values, let's say we have x is equal to 5 and we have y is equal to 7. When we want to get the value of x plus y, we can now say z is equal to x plus y. Okay, and when we print z, we will see that the value of z is the sum of x and y, okay, which is 12. The same way we have the subtraction operator, which is minus. Now when we say, let's say y minus x, so we don't get a negative value. When we use the minus sign, we are performing a subtraction of operation. Okay, when we want to multiply, we use an asterisk like this for multiplication, and 5 times 7 should give us 35. We have that there. Right, when we want to divide, let's change the values here. Let's say 10 divided by 2, and we'll use a forward slash for division, so we'll say x over y. So for division, we use the forward slash, and so when I'll clear and then run, we have 5.0. So every time we have a division operation, right, the data type of the value returned is always a float. It always has a decimal point, and the reason it does this is that sometimes you have remainder and sometimes you have whole number. And so if it's a remainder, let's say we say 7 divided by 2, for instance, we can now get 3.5. okay, but there is another operator we call the modulus operator, written modulus, modulus, like this. It is written with the percent sign. Now what it does is that when you say x modulo y, it doesn't give you x divided by y, right? It gives you the remainder of that operation. So we say 7 divided by 2 is going to be 3 remainder 1, and normally when we do the division with the forward slash, it gives us 3.5, but now it's going to give us just the remainder of the division operation. So every time you use a modulo, it is going to divide the variables or the values and give you the remainder of the division operation. And so when I clear this and I run, you will see that we have 1 because it gives us the remainder. Now we are going to see how this is useful as we go along. We also have exponentiation. Let's say I want to say 2 raised to the power of 3, right? So I'll say x, I'll put double asterisk, raised to the power of y, and this should give me 8. 2 raised to the power of 3 should be 8. That's 2 times 2 times 2, right? And so when I clear here and I run, I'll get 8. So we use double asterisk for exponentiation. But sometimes you want to return the integer part of a division operation, like to the nearest, rounded to the nearest whole number, like we did 7 and 2, like this. We have the floor operator written with double forward slash like this. So instead of giving us 3.5, rounds down to the nearest whole number. And so when we do 7 divided by 2, it's going to round down and give us 3 rather than giving us 3.5. okay, but we can do something like, let's say 9 divided by 4, and then we print this and we have 2 because it rounds down 2 remainder 1. It doesn't give us the remainder part. So the next operator we're going to look at is the assignment operator. And assignment operator is just when we want to assign a value to a variable. We've seen one from the beginning where we use the equal sign. When we assign a value of 9 to x, we use the equal sign. The equal sign is an assignment operator. Sometimes we do write a function, or when we build our softwares and we want to count, maybe we want to count the number of something, and we use a loop and we see the first one, we want to add 1 to the first, another 1 to the first, and it keeps incrementing, right? So maybe you want to count the number of students that came to class, and it has to count them one after the other. There's an operator we can use to add a value to a previous value. Let's say we have x is equal to 5 and we want to add 1 to the value of x. we'll say x is equal to x plus 5, right? Or we'll say x is equal to x plus 1. We want to add 1 to it. So x is 5. We want to replace the value of x, which is 5, with that value plus 1. We can write this as x plus equal 1. And so when we print x now, it should be 6. So the plus equal is add to a previous value and we assign variable a new value, which is the value of the computation. The same thing with minus equal. The same thing we do with forward slash equal. The same thing we do with times equal. So forward slash is division. The asterisk sign is multiplication. And the same thing with modulo equal. When you use modulo equal, it divides the existing value of the variable by a new value, updates the value of the variable to the remainder of that division operation. Okay, we also have things like floor equal. Every operator we just looked at in the arithmetic operation, you can do that and equal. Alright, we have other operators. You can research more on the assignment operators that we have. You can use different type of bitwise operations also, and use x ampersand equal s and equal 1, things like that. Research deeply about this. I only touch on the ones we most commonly use. We also have something we call a comparison operator. The comparison operator takes two variables or values or more and it compares them. We have several comparison operators. We want to look at whether two values are equal. Let's say x is equal to 5, y is equal to 7, and we want to ask if x is equal to y. So we'll do x double equal is what will give you. Now when you compare two things, you always get a yes or a no. In Python, we get a boolean which is true or false. So if x is equal to y, it will print out true. If the values are not equal, it will print out false. So we have false because x is 5, y is 7. Alright. If you want to see if they are not equal, you put an exclamation mark equal. So if x is not equal to y, it's going to print out true. If x and y are equal, it's going to print out false. So because they are not equal, it's true. Then we have the greater than sign and the less than sign. We put greater than. Is x greater than y? It's going to print out false. And we'll do less than, which will print out true. So these are comparison operators that you're going to see most frequently. But there are some times that you want to see if it is greater than or equal to. So let's say is x greater than or equal to. Use the greater and equal sign at the same time. It is less than, it is not equal to, so it will get false. Alright, and then if we want to see is it less than or equal to, we'll get true because it is less than. So if one of the conditions satisfies, if it's less than or if it's equal to, we'll use that operator like that. Then we have other sets of operators we call logical operators, and these operators just like you use and or not, things like that. So let's say for instance, I want to compare three sets of things. Now this is very important that you understand, because you can't build your softwares without this basic understanding of what we have done so far, and we're going to see the application of that if you take the advanced full stack Python course, and at some point towards the end of the course we are going to explore to see how this applies to your daily programming. So let's look at the logical operators. Let's say we have x is equal to, so let's say x is equal to 7, then we have y is equal to 4, and then we have z is equal to 2. We want to have more than one condition, and I'll give you an example before, well, a real life example before we do this. Let's say you have a website, and on your site you only want people 18 years and above to register for an account or to be able to access certain pages. You want them 18, and let's say you only want females, for instance, you don't want males, and you want to compare the person's registration details. You want to say is the person greater than 18, greater or equal to 18, and so it's two conditions that must be true, and is the person female. If you want to say you want everybody must be 18 and above except the person is a female, so you say is the person greater than 18 or is the person female. When you use an or operator written or, you are either or, which means one of the conditions must be true. If you use an and, all conditions must be true. If you use a not, it has to be the reverse of the condition. Okay, so let's do it. If x is greater than y, and then we use and x is greater than z, we want to do something. Print x is the largest number. So this is an example. When we compare two things, we want to see if x is greater than y. We want to also see if x is greater than z. We use the and operator, and we'll print x is the largest number, because x is greater than y evaluates to true, x is greater than z evaluates to true. True and true is going to give you true. Okay, and which will now print x is the largest number. All right, but let's use an else statement and say print if the condition is not true, print the condition is not true. All right, and so let's say if x is less than y, so let's make the condition not true. X is less than y will evaluate to false. X is greater than z will evaluate to true. True and false is always false. Every time you see a false, the evaluation is false. So if you have true, true, true and you have false, it's always going to be false. The only time you get a true is when all conditions are true. All right, so let's run this and you see that it prints the condition is not true. Okay, because one is true and one is false. But if we use an or operator here, now it's going to say one of the conditions must be true, and then it's going to be true. All right, so x is less than y is false, and x is greater than z is true. So true or false. So let's see what this evaluates to. So we want either one of them should be true. X is the largest number because we use an or. Okay, but if we say not, so let's say if not here, so this condition will evaluate to true, which gives you x is the largest number. But we want the reverse of it, and then we use not, so which will give us the condition is not true because we use not. Now I'll tell you where this not is also useful in when you're building your softwares. So if you want to just get values from the database and you want to say there are several values, you don't want to say if x is equal to 18 and this is equal to this and this is equal to this. Maybe the condition you don't want there is the not. Let's say for instance you have 5 different, maybe a row based system, you have 5 different rows, right? And all 5 rows can access several pages, but there is a particular page that you want everybody apart from, let's say for instance, the customers to be able to access. So you don't say if not custom, you want to say if not customers, right? So every other thing that is not a customer should have access. So those are the application of the not in real world situations. Then we'll have something like the identity operator. So we use comparison, right? We compare two things, but what we compared are the values. But when we use identity, we are not comparing the values, but we're comparing the object itself and the memory location itself. So let's say for instance, identity operator is when you use is, right? You want to check if something is something. One example is when you want to check if the data type of this is an integer. For instance, you want to have a form and you want people to fill in values, and one of those conditions is that the value must be a number, like let's say age, and they fill in a string there, and you want to have a backend control to see what they filled in. You want to use the identity operator to say if this is maybe an integer, if the data type is an integer, then you can accept it. If it is not, you can reject it. Or if it's like an input and it always comes as a string, and you want to see if it is a string, convert it to an integer, things like that. So these are the applications of identity operators. So we can say, let's say print x is y, okay, and run. So it's false because x and y are not the same, okay. But if I say y is equal to x, we run this, we have true because now we're talking about the same object. All right, so we can use is not also. So x is not y, this will now be false, and when I put y is equal to 5 and I say x is not y, we'll have true printed out. So we have other operators. We have the membership operators, which is in and not in. Those are also very useful when you want to get, I'll give you an example of projects I've done. We want to cluster data by age group, and you look at the ages of all of the clients or of all of the people you're clustering the data, or we look at all of the ages of the record you have, and you want to have age group like 0 to 4, 5 to 9. You can now say if age in and then list if it's 0, 1, 2, 3, 4, then you want to pick up that data. If age in another group, or you can have some constants where you define age group 0 to 4, you will get a list of the numbers that are 0 to 4, right? And when you say if age in, that's values from the constant or from the values from the list. We're going to look at live examples of this as we go on. So let's say if x in, let's say x is, let's put it in a list 1, 2, 3, 4, and so we'll say if z in x. So we want to say if z in x, we want to print z is an item, z is an item in x. Okay, So let's clear this and run. And so we say Z is an item in X because Z is 2. But let's say Y. Y is not in X. Right? So it's not going to do anything because there is nothing to do. We didn't give it a condition to evaluate if this is false. And so we use the else print Z is not item in X. Okay, so let's make Z to be 5 here, right? And we're comparing Z. So we have Z is not an item in X. Okay, so these are the ways we can use the membership operator. You can also say not in. Okay, if Z not in X, Z is an item in X, or Z is not an item in X, and if not, we say Z is an item in X. Okay, Z is not in X, so we'll have it is not an item in X. And if we have Z to be 3, then we will have Z is an item in X. So we have other operators, the bitwise operator, for which we use the ampersand sign like this. We have the OR operator, we use this symbol. We have the XOR, we use this symbol. We're not going to look at all of these operators in this course, but you need to know what exists and how to use them. So you can research further about the bitwise operators and how they are used. Okay. We also have something we call operator precedence. Now, in mathematics, we did something like BODMAS, where we look at the precedence of operators when we are evaluating values. For instance, let's say we have something like 9 plus 4 times 7 divided by 2. Now we have this value. There are several operators here. There is something in a parenthesis. There is a plus sign. There is a multiplication sign. There is a division sign. Operator precedence in Python, the parenthesis has the highest precedence, just like in mathematics. Every time you see something in parentheses, it will be evaluated first. If the parenthesis was not here, then we'll look at the next operator precedence that is higher in all of these operators that we have here is the multiplication and division. They have equal precedence, and when the precedence are equal, you go from left to right. So multiplication exists first, so you say 4 times 7, right, which will give it 28. You divide 28 by 2, give you 14, and then you add it to 9, and then it gives you 23. So if we print this, we should get 23, right? And so we have 23 printed out here. Now, in the event that there's a parenthesis here, it changes the order of evaluation, where 9 plus 4 is evaluated first, which will give us 13, right? Then 13 times 7, and then that answer divided by 2. And so what we'll get might now be totally different from what we previously. And so we'll get 45.5. So if you evaluate things not in the order of precedence, you're going to have issues with your final answer. Now the order of precedence is the parenthesis comes first, then exponentiation, when you see double asterisk, comes next. Then you have all of the unary plus minus comes next, and then you have multiplication, division, the floor and the modulo have equal precedence. So when you see those ones, you evaluate from left to right. And then after those ones, then we have the addition and subtraction, which have equal precedence, which means you evaluate from left to right. Then you now begin to have the bitwise operators, and then the logical operators are down in the chain of precedence. So when you have logical operators in your evaluation, it is most likely what you will evaluate last. So this is where we end this lesson. Thank you and see you in the next lesson.